all ready in the back? All right, let's go. So, announcements. First of all, for our off-campus students.
I'm Steve Skerlos. I'm a professor in mechanical engineering. I also serve as director of sustainability education programs in the College of Engineering. And I do research in sustainable design and manufacturing, and I teach courses generally on the same topics. This is a graduate course in sustainable design of technology systems. So we're trying to teach students about sustainable design. What does it mean? How do you do it? And actually trying to give them experience by sort of living through the process of trying to design a sustainable system.
You know, is this an example of a sustainable design or not? What do you think? Looks good.
Depends on those internal components and how they're handled more than anything, because those are all still.
Why do you say that?
I mean, a lot of the.
We've got a tree here, man.
But a lot of the impact is coming from all those electronic components.
But this tree weighs a lot more than those components, right? No, you're onto it, right?
The class has 60 students. The majority are mechanical engineers. There are a significant number of environmental engineers, chemical engineers, as well as students from the School of Natural Resources and Environment, and a few from the business school. Sustainability is inherently a multifaceted issue, and there's a significant amount of research that needs to go into each project. And the notion of one engineer or one individual sitting behind a computer screen and achieving sustainable design is a bit of a fallacy. It's by nature a team topic. We want to get as many viewpoints into the design process as possible, as many students working together. They have complementary skills, and we try to accommodate those when we actually form the teams. Diversity is important from that standpoint, diversity of skills, making sure they're complementary in the team. That's important. We also look at schedule compatibility. We also distribute demographically, but also in terms of GPA. And we found that's important to avoid clusters of GPAs. So we put all that together, and then we do account for the preferences, what type of projects they want to work on. What I try to do is create a situation where groups that might be a minority or underrepresented are not outnumbered on a team. You're not going to get a team of 4 women. Maybe it's 2 women and 2 men, right? And we try to work that way. I might prefer teams of 3. This is a large class, and so teams of 4 are manageable, and we have a long history of using teams of 4 in our senior design class in mechanical engineering, so that's a comfortable number. 5, in my experience, is too many. There is a team charter we actually ask them to fill out. And it begins to get at operating norms, how they're going to settle conflict, their schedules. So I can meet with each team, even though it's a big class, for 15 minutes each week. And actually the GSI can meet with them for another 15 minutes. So they actually get about a half an hour of strong input each week. So I actually give them challenging quizzes as well, and those are individual. I will write about 10 multiple choice questions that are fairly challenging from the pre-read or the pre-class video. And they have a week after class to take that. It's just a 5-minute quiz. The first question that we ask is, if you were to divide up the quantity of work, how would you divide that up among your teammates? If you do this for a long time, you start to see certain behaviors of maybe students who aren't working as hard.